Today I am going to study one data pre-processing called column normalization. CULUMN, column normalization. So this is a very important concept that we are going to study today. But before that, so let me see, will I use this entire? Okay. So before that, before I move ahead, let me draw a data matrix here to discuss the further. So you can also draw along with me. It's a simple data matrix. We have already drawn the data matrix during the last session. So there is not a big thing here. So let's draw a data matrix. Let's say this is my data matrix. And I am giving the name X represent my data matrix. Fine. And let's suppose these are my features. So here, this is my F1, this is my F2, this is my F3. Here, there is Fj and till, let's say, Fd. And here we have X1, X2, X3, Xi, and Xn. These are my columns and these are my rows. So along the columns, these are the features, and along the rows, these are my data points. And we have also studied that this we can represent it Xi transpose. Why we are doing this? Because by default, our data point, by default, it is a column vector, and we want to convert this into a row vector. That's why I'm using Xi transpose. And this is my Y. This is a level, and I'm writing this as Y. And this matrix is N cross D, and this is my N cross 1. I suppose still here, there should not be any issue. So let me explain you this, what we are going to discuss. So let's imagine if I am given this data matrix. So this is my data matrix that it is given to me. And in this data matrix, these are my columns. Fine. Which are my columns? This F1, F2, F3, Fj till Fd is a feature, which is a column. And each of my rows, this X1, X2, X3 till Xn is my data points. Those my data points are along my rows, and these features are along the columns. And this data point, if I will take any row of data, let's take this row of data, this Xi row of data, it should be Xi transpose. Why this is Xi transpose? Because by default, my this is a column vector, and I want to convert this into a row vector. Fine. Now, right now I'm not looking at this Y, but you know this is my level. Y is my level, and these are, let's say, some of the level Xi, Yi till Yn. Fine. This is my N cross D, and this is my N cross 1. Till here, there is no issue. Fine. Now, so there is something, let me write it. There is something called data pre-processing. And what is this data pre-processing? So the term pre-processing basically refers to some kind of mathematical operations and transformations that we will do on the data itself before we go and do some other more complex data transformations. For example, let's say I want to reduce the dimension so as to visualize the data more efficiently even before we build machine learning models. So we do pre-processing basically means what type of operations do you perform before we actually build the machine learning models. This is what I mean. Let me explain you this by writing it down so that it is easy for you to understand. So let's say, first of all, what I used to do, first of all, we obtain a data. So my first thing is obtaining the data. So let's say I obtain data. This is my first process. After I obtain the data, then I perform some data pre-processing operations. And what type of pre-processing I will operate, it depends upon my problem that I am dealing with. Fine. So I do some data pre-processing operation. Fine. After I do, and as a part of data pre-processing, there may be a multiple operations. It is not necessary that it is only one process. It may have inside this data pre-processing operation, we can have multiple operations here. Fine. We can have multiple operations that we do as a part of my data pre-processing. And one such operation is called column normalization. One such data pre-processing operation is called column normalization. That I have.
Sir, can you please repeat this one that the processing of data one?
Okay.
Standard.
Okay. I will be repeating. Let me just write it down and I'm again explaining you. I will again explain you. After this data pre-processing, I do data modeling. Let me just first write this work, this flow, then I will data modeling. And there comes the data dimension reduction. Fine. See what I want to do. See, first, my agenda is I'm learning column normalization. Fine. First of all, I obtain the data. There is some data that I got from somewhere. After you obtain the data, the second operation that you do is called data pre-processing. See, this comes under the exploratory data analysis. When you actually build a machine learning model, we will learn all these machine learning models later. So when actually you go and build the machine learning model, you first prepare your data to so that your machine learning model will perform well on that data. So there are a lot of data pre-processing operations that we need to perform before we actually build the machine learning model. And what type of pre-processing we will do, it all depends upon the type of data we are having and the type of problem we are going to solve or the type of use cases we are going to solve with the help of that data or what is the end goal to achieve. It all depends upon that kind of pre-processing operations we will do. Actually, the data that you get from somewhere, they are in the very raw form. That means it may have a lot of problem inside it. So that is not a clean. So we do a cleaning operation. This is also called cleaning process, data cleaning. Fine. So as a part of a data cleaning, there are a lot of data cleaning or data pre-processing or operations. As a part of data pre-processing operation, one such operation is column normalization that we will study, that we are studying right now. Is it okay for you? समझ में आया आपको?
Yes, sir.
समझ में आया ये?
Yes, sir. आ गया.
So after that, I have already told you it's very problem specific. So we will learn about some of the very important data processing techniques as and when they will come. So before we go into n-dimensional data, we want to learn n-dimensional data reduction. So before we go and deal with this n-dimensional data, we want to learn n-dimensional data reduction. This is my dimensionality reduction. And this dimensionality reduction is a part of a basically data modeling operation. So dimensionality reduction is basically a part of my data modeling. What is this data modeling and all those things that we will learn? Just just understand at this point of time that before you perform data modeling, and dimensionality reduction is also a part of data modeling, I need to perform a process called data normalization. Now let's look at it. Now let's understand one more thing. So what I'm doing, let me just copy this entire thing, and I am taking this to the next page. Just copy this entire so that again I don't have to do the same thing. This is copy, and let me paste it here. Fine. Fine. Now, let's suppose this is a new data. This is a new data matrix I have built on the next page. So you understand that this is a feature. These are the features. These are the columns that represents a feature. So let us assume I have this D features from I1 till FD, F1 till FD. So I have 1, 2, 3, 4, 5 till n data points, and each data point is having D features. So we can add data point, we can write it like this. Now, my yi is this, these are the things that is clear to you. First of all, let me tell you what is column normalization. What it means, what is column normalization? What it means, you take each column. Let's say I am taking this column. Let's suppose here I am taking this column Fj. Fine. So I am taking this column Fj, and this column is having these datas A1, A2, A3 till this is my, let's say, AI, and let's say this is my AN. These are the datas. Similarly, let's suppose I am taking this column, some other column, my F3 column, and this column is having my data, some data like B1, B2, B3. This is, let's say, BI and BN. These are the two columns I am right now taking to explain you the column normalization. Now let's understand. So these features, the features that if you take a case of since each column corresponds to a feature, let's suppose if you take the case of iris flower, if I will take iris flower, so iris flower, so these features will be sepal length, sepal width, petal length, and petal width. Fine. This is just to refresh your memory and what features are all these. So let's assume on this column Fj, I have this A1, A2, A3, AI till AN data. So AI here corresponds to xi data points or ith data point. Fine. And x1 corresponds to this thing. So first of all, what I will do, I will process my first column, or let's take, I am processing any one of the one column. Then I will process the second column, so and so forth till D column. We have D column here in the features, we have D column. So one by one, I will first do first column, then second column, then third column, likewise till D column. In each one of the column, individually, or you can say separately, I will process each one of the column. And what process I will do? I will perform column normalization. So column normalization for one column of data, I will perform column normalization for, let's say this is one column. I will perform column normalization for this column of data. And the same thing is applicable for all columns of data here. Same process. So I will show you how to perform the column normalization for this particular column, let's say. And whatever process I am going to follow in this column, same process is applicable for all the columns of data here. That is from F1 till FT. Fine. So in if you remember in iris flower, we have 150 in iris flower data set, we have 150 data points, 150 flowers. So 150 flowers means we have 150 data points. Fine. So if for each column or for each features, I will perform the column normalization for 150 points inside that column. Fine. Then I will the same thing. So let's do it. Let me take you to a next page and let's do this thing. So what I am going to take, I am going to do here from this FJ column. From this FJ column, I am writing all my data points and I am going to perform the column normalization on this column. That's why I am taking the data of all the data points of FJ column. So if I take the data points of FJ column, what will happen? So this is in FJ, we have A1 till AN data points. So let's write it. I have this A1, A2, A3. This is my AI and till AN. We have total AN, that is N values for N values of N values of FG. Fine. Now, if this is A1, A2, A2, A3, so then what I will do, I will take the maximum value of the in this data point, in this data A1 till AN, I will find the maximum value of AI. So what I will do max of AI. And let's suppose I am giving the notation this A max. So इन सभी डेटा पॉइंट A1 से लेके AN तक जो मैक्सिमम इनमें से होगा, मैं उसको मैक्स AI लिख रहा हूं एंड आई एम गिविंग इट अ वैल्यू A max. This is just a representation. What if this will be the A max, then what it means? It is greater than equal to AI. If A max is the maximum value among all these points, then A max should be greater than equal to AI. And here my I belongs to 1 to N. Similarly, if I want to find the minimum value, minimum among these AI, I am writing minimum of AI. So I am giving it a representation A min. And A min should be less than equal to AI. If A min will be the minimum value, then definitely it will be less than all the AIs. Here also, I will be from 1 to N. Now, till here, everything is fine.
I want to recapitulate that. Can you please go back to the matrix one diagram which you have made Yeah, just a second, sir. I just want to have a look over it. Okay, sir. Okay.
So now, if let's say I want to transform this data, so let me define something. This is my, let's say, A1 dash. This is my A2 dash. This is my A3 dash. Likewise, this is my AI dash. And similarly, this is my AN dash. So I'm going to explain you what is this dash means. So now from this value, which is given, which is already inside my data from this column, I will transform this A1 to A1 dash. I will transform this A2 to A2 dash, A3 to A3 dash. This transformation, that means I want to create a new data vector. So this is basically my new, I can also write, this is basically my new data vector. New data vector. Now, why this is a new data vector? Because I am showing you. So now here comes what is my A dash. What is my A dash? A1 dash is. So basically, this A1 dash is here. My A1, let me write, A1 dash here is equal to AI minus A min by A max minus A min. And
So ये डैश का फॉर्मूला है.
यस, अभी अभी मैं एक्सप्लेन करता हूं आपको. बिलोंग्स टू 0,1. फाइन. A1 डैश. अभी क्या है, मैं आपको समझाता हूं, ये समझो. ये मेरा एक कॉलम ऑफ डेटा है. इसमें कोई दिक्कत समझ में आ रही है? ये कॉलम FJ कॉलम ऑफ डेटा को मैंने ले लिया, इसको मैंने लिख लिया यहां पे. ये A1 से A है. अब मैं क्या कह रहा हूं कि इनमें से जो मैक्सिमम वैल्यू होगा वो A मैक्स होगा. कोई भी वैल्यू हो सकता है, मैंने उसका रिप्रेजेंटेशन उसको दे दिया A मैक्स. कोई प्रॉब्लम? और इनमें से जो मिनिमम वैल्यू होगा वो होगा A मिन. ये A मिन है. अब मैं ये कह रहा हूं कि मैं इसको ट्रांसफॉर्म कर दिया हूं, मतलब इसके ऊपर मैं कॉलम नॉर्मलाइजेशन परफॉर्म कर रहा हूं. तो जो नया डेटा, इसके ऊपर अगर मैं एक कॉलम नॉर्मल, दिस इज बेसिकली, अगर मैं इसको ऐसे बोलूं, अभी क्या होता है कॉलम नॉर्मलाइजेशन वही हम समझ रहे हैं. अभी आप ये समझो, अगर मैं इसके ऊपर कॉलम नॉर्मलाइजेशन, जो हमारा फंडा है था, स्टार्टिंग में हमने क्या स्टार्ट किया था, कॉलम नॉर्मलाइजेशन. अगर मैं इसके ऊपर कॉलम नॉर्मलाइजेशन परफॉर्म करता हूं, तो ये जो डेटा पॉइंट्स हैं हमारे, ये सारे चेंज हो जाएंगे, कुछ और डेटा हो जाएगा ये. तो ये जो नया डेटा आ रहा है, इसको मैं बोल रहा हूं A1 डैश. ये A2 कन्वर्ट हो गया A2 डैश, A3 कन्वर्ट हो गया A3 डैश, AI कन्वर्ट हो गया AI डैश में. सिमिलरली जितने इसके अंदर डेटा पॉइंट्स हैं वो सारे मैं कन्वर्ट होने के बाद, डेटा नॉर्मलाइजेशन परफॉर्म करने के बाद ये हो गया. लेट्स ऐसा मान हुआ. अब मैं ये कह रहा हूं कि ये AI डैश है क्या? AI, this is basically my AI dash. फाइन. अब मैं कह रहा हूं कि AI डैश क्या है. AI डैश में ये कह रहा हूं AI डैश इज AI, मतलब अगर I के जगह यहां माइनस A मिन बाय A मैक्स माइनस A मिन. और ये AI डैश की जो वैल्यू आएगी, दैट विल बिलोंग्स टू 0 and 1. ये 0 एंड 1 के बीच में ही रहेगा। ये वैल्यू जो हमारे पास ओरिजिनली
तो
था,
सर हर एक की वैल्यू डिफरेंट होगी, ए वन डैश की वैल्यू 0 से, अच्छा ए आई डैश की ही 0 से 1 के बीच में फिर।
लेट सपोज A1 की वैल्यू मेरी कुछ भी थी, वॉट एवर एनी वैल्यू, बोलो आप कोई भी वैल्यू।
कोई भी मैंने सर 3 ले लो,
हम्म
3 ले लो सर।
3 ले लो। मैं कह रहा हूं A1 की वैल्यू आपने 3 लिया, लेकिन A1 डैश की वैल्यू हमेशा 0 और 1 के बीच में ही आएगी। अब आप बोलो कोई भी वैल्यू बोलो A3 की, कोई बड़ा वैल्यू बोलो।
8।
8, मैं कह रहा हूं 8000 ले लो। लेट्स टेक इट A3, लेट्स टेक A3 एज 8000। मान लो A3 मैं कह रहा हूं 8000 है, लेट सपोज, ठीक है। बट ये वैल्यू जो मेरे पास आएगी A3 डैश की, इट विल ऑलवेज लाई बिटवीन 0 एंड 1। ये फॉर्मूला हम लोग अप्लाई कर
सर
रहे
तो
हैं।
कोई भी वैल्यू फिर आएगी तो इसके अंदर वो 0 से 1 के बीच में ही रहेगी।
करेक्ट। इसके अंदर कोई भी वैल्यू आएगी, वो यहां पे आफ्टर कॉलम नॉर्मलाइजेशन उसकी वैल्यू हमेशा 0 से 1 के बीच में ही फॉल करेगी। ये समझ में आया आपको? अब ये क्यों फॉल करेगी 0 से? ये हमारा फॉर्मूला है, या ये हमारा, आप समझ लो ये फॉर्मूला है। हम किसी भी डेटा पॉइंट्स को, किसी भी कॉलम को हम के ऊपर जब हम कॉलम नॉर्मलाइजेशन परफॉर्म करते हैं, तो हम ये चीज यूज करते हैं, ये फॉर्मूला यूज करते हैं। और ये फॉर्मूला यूज करने से क्या होता है कि कोई भी डेटा पॉइंट की वैल्यू हमेशा 0 और 1 के बीच में ही फॉल करेगी, 1 से ऊपर नहीं हो सकती। कैसे नहीं हो सकती है, इसको भी हम लोग देख लेते हैं, क्यों नहीं हो सकती है। ये भी एक क्वेश्चन है। लेट सपोज कि मैं चाह रहा हूं कि मिनिमम ये इनमें से A1 डैश A2 डैश समथिंग जो भी है, इसमें से मिनिमम वैल्यू क्या होगा? ए मिनिमम डैश, करेक्ट। ए मिनिमम डैश क्या होगा? लेट सपोज ए आई के जगह हम क्या डाल सकते हैं? ए मिन। ए मिनिमम डैश में ए आई क्या होगा हमारा?
ए मिनिमम।
ए मिनिमम होगा, करेक्ट। तो ए मिन,
यस सर।
और ये हमारा ए मिन ऑलरेडी है, ये हमारा ए मैक्स है, ठीक है। तो इसको अगर मैं ए मैक्स भी लिख देता हूं, माइनस ए मिन लिख देता हूं, ये ए मिन कैंसिल हो गया, इसकी वैल्यू क्या आ रही है? 0 आ रही है ना। मतलब
यस सर।
ए मीन डैश इज इक्वल टू 0। अगर मैं यहीं पे बात करता हूं लेट से ए डैश मैक्स, तो क्या होगा? यहां पे ए आई की जगह क्या होगा? ए मैक्स आ जाएगा। ए मीन में क्या होगा हमारे पास? ए मीन ही आएगा। और ये क्या आ जाएगा? ए मैक्स माइनस ए मीन। ये कैंसिल होगा, ऊपर नीचे बराबर हो गया, कैंसिल हो गया, ये मेरा 1 आ गया। तो आप क्या देख रहे हो कि ये मिनिमम वैल्यू हमारा कितना आ रहा है? ए मीन 0। एंड मैक्सिमम वैल्यू कितना आ रहा है? मैक्सिमम वैल्यू ए डैश कितना आ रहा है? 1। इससे ये व्हाट आई वांट टू से कि आफ्टर परफॉर्मिंग कॉलम नॉर्मलाइजेशन, whatever value will be inside the column, that will automatically get converted, that will lie between 0 and 1. So by doing this transformation, you could say like this, by performing this transformation of column normalization, your value will always lie between 0 and 1. So as long as your values are real numbers, or you can say integers, you can apply this transformation by using this formula. This is my formula for applying this column transformation. When you apply this column transformation, your output column or your output value will always lie between 0 and 1. Why it is always 0 and 1? Because if I put minimum of AI here, I'm getting this 0. In this formula, if I'm putting my minimum of AI, I'm getting 0. That means the value of A min dash will always be 0. And if I'm putting A max, I'm getting this thing. Summarize it. If we have A1, A2, A3, till let's say this is my AI and this is my, let's say, A, D or AN, whatever. What is this thing? AN, okay. This is my, let's say, AN. And here AI belongs to my this real number. Now, if I perform column normalization here, column normalization, what I am getting? I am getting this A1 dash A2 dash A3 dash, this is my AI dash till AD dash, such that my AI dash belongs to 0, 1. This is a summary. And this is true for every column. Is this fine? Now.
Yes, sir.
Now let's understand, this is the next part. Let's understand why we are doing this. Why we perform. This is why we are doing this. So why we do column normalization. So for this, let me take one table. Let me first draw one table. Then I will explain you why I am doing all these things. Fine. Let's suppose and let's suppose this is my F1. Sorry. So if I take this, okay. So this is, let's suppose F1 and this is my F2. And my F1 is, let's suppose this is F1 is H and this is my W. So what it means, suppose I am collecting heights. This H is my height and W represents my weight. Or you can say this is my two features. I am taking two features, height and weight. H represents my, H here is my height and W here represents my weight. And this is this data. I am taking the data of student. Let's suppose I am collecting the heights and weights as two features from a group of student. So my first feature, I am writing it as H. This is my first feature. I am writing it as H. And my second feature, I am writing it as F2 as my weight. Now, in which scale I am collecting my heights? This is very important. In which scale I am collecting my heights? Let's suppose I am collecting heights in centimeter. You can collect height in anything. You can collect it in meter. You can collect it in centimeter. You can collect it in kilometer. Whatever unit you want, you can collect it. But all should be same. One column, if you are collecting in centimeter, all the data in that column should be in centimeter. This is the only thing that you should keep in mind. So let's suppose I'm collecting the height in centimeter. So let's suppose this is, if this is height, let's say this is my 162 centimeters. Some student is having, one student is having 160, one student is having 172, one student is having 182, one student is having 155, one student is having 160. Likewise, these are the heights of student. And the corresponding weight of the student is, let's say this is my 56, this is my, let's say 72, this is my, let's say 84, this is my, let's say some height, it's, let's say 95, this is my 76. And likewise, I have taken some random values here. Fine. These are my fine. And these are my, let's say, data points. So these are my 1, 2, 3, 4, 5, so on, so forth. Till, are you getting my point? Till, let's say, n data. So all heights are collected in centimeter. And let's suppose the height that I am collecting, this height, which I have collected in centimeter. And the weight, I have collected in kilograms. Kilograms. One feature is in centimeter. This feature is in centimeter. And this feature is in kilogram. These are in kilograms and this is in centimeters. So what if somebody collected this data instead of this kilogram? Let's suppose here is a kilogram. So instead of this kilogram, let's suppose if somebody collected this data in pounds. So if I collect this thing, suppose this is a weight I have collected. Right now I have collected the weight in kilograms. Let's suppose someone collected this weight in pounds. Pound is also a unit of weight. So if I collect my weight in pounds, this data will get double, because approximately pound is twice kilogram. This is a approximation. Pound is twice the kilogram. So if I collect, instead of this data that I am getting, if I simply change the unit of weight, this data will get changed. Simply it will double. And if I have collected the height in centimeter, now instead of this centimeter, if I will write this in meter, this data will also get changed. Now instead of this, it will, there is a decimal point here, because I need to convert this into meter. So this unit is playing a very crucial role here. But because real world variables can have many ways of collecting data. Suppose I give you, I have not mentioned any unit. So someone will collect it in, maybe in, instead of the meter, if I will collect this this height in feet, I can also collect this height in feet. Again, the data will get changed. If I perform, this is a normal data. Now let's suppose I perform column normalization. Column normalization. Normalization here. If I perform column normalization, what will happen? So let me first plot one column. So let me first plot one column here. Oof. This is happening. Suppose I have this column, fine, and this column is having, this is my, after column normalization, this is my F1 dash, which is my H dash. And after column normalization, this is my F2 dash is equal to W dash. And these are my data points 1, 2, 3, 4, whatever, till let's say n. So column normalization, what column normalization is doing, after performing the column normalization, here this thing and this thing can have any real number values. But here, this should always be between 0 and 1. And this should always be 0 and 1. So what I am getting rid of scales. Scale. That is, I'm putting everything in the same scale. Are you getting my point? So that's what I was explaining you. When I'm creating this, my feature f1 dash, which is my height dash, the height h dash, and my feature f2 dash, and which is weight w dash, in such a way that all these values for each student, student 1 till student n, lie between 0 and 1. Now, I don't care whether they were collected in centimeters or meters or feet, or whether the weight was collected in kilograms or pounds. By performing this column normalization, I am getting both my features into one standard format. Both these features are now in to one standard format, where all the values will lie between 0 and 1. So this is one type of data pre-processing, or it's actually called data normalization. This is one form of transforming your data such that this is scale independent. That is, it is scale independent means it is getting rid of scales, putting everything in the same scale. So maximum height person will have, the maximum height person will have a value of 1. And the maximum weight the person will have a weight of 1. Now we will see this is more important later on. Simply the thing that you need to understand here, we are putting all the features in the same scale. So we will understand better how a scale actually can create problems when we will learn regression and classification techniques. After some time, we will understand why having variables in different scales could be very dangerous for your machine learning models. That's why we want to convert the data into a same scale. By putting everything in the same scale, the value will always lie between 0 and 1. Now, the next part of this is let's understand the geometric intuition behind this, because this is very important. Without understanding this geometric intuition, we are. So let's first understand the geometric intuition behind this. Let me write this. Till here, any issue, any problem, anything that you are not able to understand, please tell me.
सर बस एक बार ये लास्ट वाली स्लाइड ओपन कर लीजिए सर प्लीज.
मैं ये दे दूंगा आपको, टेंशन मत लो.
नहीं, मैंने अभी जो लिखा है मैं वो चेक कर रहा था कि मैंने कुछ वैसे नहीं दिया ना. मैं लास्ट वाला ही
कोई
लास्ट
बात नहीं,
बॉक्स
मैं आपको वैसे भी ये सीट दे दूंगा तो
कर
आप.
लिया सर.
ठीक है. समझ में आया कि नहीं अभी तक?
हाँ सर, आ तो गया.
मिस्टर संजीव, आप कुछ बोल नहीं रहे सर? एवरीथिंग फाइन टिल हियर?
हाँ हाँ, बिल्कुल बिल्कुल.
ठीक है सर. सो संजीव सर, आप गाइड करते रहेंगे हमको. संजीव
नहीं नहीं
सर
नहीं, गाइड
आपके रहे.
मैं कैसे गाइड करूंगा सर? आप बढ़िया कर रहे हैं एकदम. बड़ा
नहीं,
क्लियरली समझ में आ रहा है एक एक चीज.
तो काफी मुझे संजीव सर के बारे में इनपुट मिला, काफी तेजस्वी आदमी है।
नहीं नहीं नहीं, ऐसा कुछ नहीं है सर।
काफी
हम भी
कोशिश
अभी नए
है।
हैं सर इसमें, इस फील्ड में। आपके सहयोग से आगे बढ़ेंगे हम भी।
नहीं
काफी
नहीं, मैं भी
अच्छा
आपके
लग रहा है।
सहयोग से
जी
आगे
जी
बढ़ूंगा। ठीक
जी।
है। ठीक
प्लीज
है।
प्लीज।
अभी हम लोग सर बात करते हैं ज्योमेट्रिक इंट्यूशन।
ओके ओके। जी जी प्लीज।
तो ज्योमेट्रिक इंट्यूशन समझने से पहले मैं एक ये बना लेता हूँ। ठीक है, मैं एक एक्सिस ड्रॉ कर लेता हूँ। लेट सपोज ये मेरा एक लाइन है, ये मेरा एक दूसरा लाइन है। ठीक है, और ये मेरा एक और लाइन है, और ये मेरा एक दूसरा लाइन है। ठीक है, अब मैं इसको थोड़ा सा और एक्सटेंड कर देता हूँ। दिस इज दिस, दिस इज दिस, दिस इज दिस, दिस इज दिस, दिस इज दिस। ठीक है, अभी क्या करना चाहिए? ठीक है, this is my, let's suppose this is my feature f, sorry, ये मेरा f1 है, और मैं इसको हाइट बोल देता हूँ। एंड ये मेरा f2 है, इसको मैं वेट बोल देता हूँ। एंड ये मेरा कुछ डेटा पॉइंट्स है। लेट्स क्रिएट सम डेटा पॉइंट्स। एंड this is my, suppose f1 dash। आप लोग भी नोट कर सकते हैं अगर चाहें तो, वैसे मैं सीट आपको दूंगा। एंड दिस इज, मैं ये करता हूँ। थोड़ा गड़बड़ बन गया इसको। पूरा ये डायग्राम बनाने में मैं थोड़ा काफी वो हूँ। तो और ऊपर से मैं टैब पे नया नया सीख रहा हूँ लिखना, तो चीजें थोड़ा देखो आप, ये लाइन थोड़ा सा आगे बढ़ गया। तो
नहीं, नो इशू नो इशू।
तो मैं कोशिश करता हूँ इसको ठीक करूँ, क्योंकि समझने में ये बड़ा इम्पोर्टेंट हो जाता है, तो इसको मैं वैसे ही लिख देता हूँ। इसको मैं वैसे line- ठीक है, तो अभी हम लोग ज्योमेट्रिकली, जो अभी हमने चीजें को समझा है, तो हम लोग ज्योमेट्रिकली अभी समझते हैं कि हम क्या करना चाह रहे थे। लेट्स चेंज द कलर। और मैं कह रहा हूँ दिस इज कॉलम नॉर्मलाइजेशन। ठीक है, now let's understand, I have taken a lot of time to draw this diagram, but after seeing this diagram we will not face any difficulty in understanding the real thing. So let's understand the geometric intuition behind it. So let's stick, I'm sticking to my height and weight data that we have discussed here. So this is, so imagine uh, this is my initial data was f1 is my height and f2 is my weight. So I can represent each person as a data point in this. Fine. So let's assume my first person is, let's suppose somewhere here. Fine. The second person, let's say this here, third person here, fourth person here, likewise. this cross basically represents my person. So each person is having some height and each person is having the corresponding weight. So this x-axis is a representation of height and y-axis is a representation of weight. Now, one thing that you should know, there's a proportional relationship between height and weight. As the height increases, the weight also increases. But this is not always true. You have seen someone maybe whose height is more, but he is very lean and thin, and his body mass index is very less, so his weight may be less. Someone whose height is less, but he is very fatty, so maybe, and his body mass index is very high, so he can have. So this is this relation is not always true, but in general, it is true. Fine. So I'm representing each person with this cross symbol. Sorry. I'm representing each person with this cross symbol here. So, and yeah, and this is my F1 dash, and this is my H dash, H1 dash, and this is a diagram that I have drawn before normalization, before column normalization. After doing this column normalization, I am here. Now let's see what's the difference. So what I'm doing here, so I have transformed each of these points. So let's suppose, first, let me make you this thing. Let's suppose if I'm taking some point here, this point. So this, let's say if I represent it here on this axis, and let's say if I represent this on this axis. So this is, let's say, the height. Let's suppose this height is 170 centimeter. And let's suppose this weight is 65 kg. Likewise, you can take any point and you can find through this axis where it lies, what is my height and what is my weight. So this is 170 centimeter. You can see my height is 170 centimeter here and my weight is 65 kg. Now I have transformed each of my points. This cross represents the points, my data points. So here what I have done, I have transformed each of my data points. And what I'm doing here is I'm creating a bounding box. This is my bounding box. The box that I have created here, this box is my bounding box. And what this bounding box is, this point is my 1. This is my 1. And this is a 0. Now, can you see I'm getting this bounding box and all the data inside is lying between this bounding box. So my x is lying between 0 to 1 and my y values here is also lying between 0 and 1. None of my points is crossing this bounding box. Can you see? None of my values is going beyond 1. Minimum value is 0 and maximum value is 1. So basically, I will bring all these points into this region, this bounding box region. Basically, I'm taking this data and I'm squeezing this data without spoiling the relationship between the data points. This is very important. See, if you look at this data, there is some relationship between these points. Can you see? Relationship, I mean the distance between the points, between the 2 points inside the data is some kind of relationship between this data. So I am not destroying the relationship between. I am just taking completely this and squeezing it into this bonding box so that I am not spoiling the relationship between the data points. I am squeezing all these data point and bringing it into a square. This is my, basically, if you look, this is my unit square. This is my unit SQUAR square. Fine. So because it's a square of side, one on this side and one on this side. So this is a unit square and this is a two-dimensional data. So in high dimensional space, what happens? Suppose if I have d-dimensional data. Suppose if I have d-dimensional data. So if I have d-dimensional data, linear algebra will help. In this case, we will use linear algebra will help us to do these stuffs of interpolating the things which we learn in 2D to high dimension. Suppose if I have high dimensional space, of course, I can't draw the dimensionality here. Let's say you might have a bunch of points like this. So what's it doing here? It's bringing all those points in this space. Let's understand this with the help of three-dimensional data. So in the next slide, I am going to draw, and it's a very difficult task for me because I'm not used to drawing these things. But let me draw it, then I will explain the final things to you. So let's suppose
This thing is a bit complicated.
कॉम्प्लिकेटेड नहीं है, अभी समझ में आएगा धीरे धीरे।
नहीं समझ तो आ रहा है बट तो
समझ
इतना
में आ
सारा
रहा है?
एकदम से इतना सारा मैथ्स आ गया ना, थोड़ा
नहीं
थोड़ा
अभी
वो आने लग गया.
AI is AI is nothing, it's a maths. एक्चुअली मैं बताऊं
A
कंप्लीट
bunch of combination of basically stats, economics and
stats
mathematics.
every मतलब बेसिकली दे आर द एडवांस मैथमेटिक्स स्टैटिस्टिक्स। तो और अगर आप समझने में मजा आएगा आपको, और मैं यहाँ हूँ इसलिए हूँ कि आपको समझने में दिक्कत ना हो, ठीक है। तो मैं अभी एक थ्री डायमेंशनल वो ड्रॉ करता हूँ अभी, इसके बाद फिर मैं आपको ये लास्ट थिंग आज का मैं समझाता हूँ, फिर हम लोग और कुछ चीजें देखेंगे। ये अगर
अनुप,
हाँ सर।
एक ना हमको लास्ट के 15 मिनट्स जब समझाने के बाद ना संजीव है यहाँ पे लाया है ना, ऑल ऑल्सो इज टेकिंग द सेशन, राइट? उनके साथ डिस्कस भी करना है, ठीक है?
हाँ तो ठीक है, मैं कर लूंगा वो, आप टेंशन लो। ठीक है, इसके बाद में एक यहाँ पे let's suppose something like this, draw something like this। आप भी ड्रॉ कर सकते हो अगर चाहो तो।
तो ये इसी में आया ना ज्योमेट्रिक इंट्यूशन.
ये ज्योमेट्रिक इंट्यूशन का ही पार्ट है, ये मैंने 2D डेटा में दिखाया है, अब आपको थोड़ा 3D में दिखा रहा हूँ, आपका विजन और थोड़ा क्लियर कर रहा हूँ, है ना। 2D तो आपने देख लिया, अब 3D में भी देख लो, है ना। तो ठीक है, अभी लेट्स सपोज दिस इज समथिंग, let's suppose this is now This is something called, let's suppose f1 dash. This is something called, let's suppose f3 dash, something called f dash. Yes. And this is basically अभी let's suppose क्या कहते हैं. Now let's come to the main thing. So suppose if instead of this two dimensions, we have seen the geometric intuition behind this with the help of this two-dimensional data. Now suppose if this is a three-dimensional data. So if this is a three-dimensional data, let's suppose this is my this is my f1, this is let's say my f3, and this is let's say my f2. These are the three features. And let's say this feature is, this is my height, this is let's say my weight, and let's say this is some other feature, blood cholesterol. I have taken. These are the three features which I have represented in the three axes. Of course, this cholesterol is measured in a different scale. And even I don't know in which scale it is measured, because it's all about the medicine part, and doctor will understand it better. But the scale, but what scale cholesterol is measured, I don't care, because if I do column normalization. Why I do? Because in whatever scale it may fall, it doesn't matter for me until only if I am performing this column normalization. Because what is the first thing that column normalization? It makes the data independent of scale. Fine. So if I create my new feature, this is my f1 dash, this is my f2 dash, and this is my f3 dash. So all of this data will lie inside this unit cube. This was a unit square because it's a two-dimensional data, and this is my unit cube. So whatever data is lying here, I don't know, I will just put this inside this unit cube. Fine. So if this is a unit cube, so definitely this value is 1. This will also be 1. It will be something like 1 1 0 0. One value will be 0 1 0, and 1 will be like 0 0 1. Coordinate. This is a coordinate. So, but basically this is my cube. So what actually this column normalization does is, it takes your data from n-dimensional space. This is my n-dimensional space. Fine. It takes your data from the n-dimensional space. Anywhere in n-dimensional space, your data lie anywhere in the n-dimensional space. We don't know. So column normalization will take that data and put all of this data in a unit height. This is a unit cube. Fine. But let's say here we have a three-dimensional data. So we have put this cube here. Here we have a two-dimensional data. So we put this square here. But if the dimension is, there is n-dimensional data. N-dimensional data. For n-dimensional data, we put called unit hypercube. So in the same n-dimensional space, it will create a unit hypercube and put it inside that unit hypercube. So it's basically compressing, or it's actually squeezing all of this data into a unit cube or a unit cuboid or a hypercube. And we will see later why this is all useful. So at least one thing that you understood here is we are getting rid of scale. We are getting rid of whether the data is in centimeters, meters, feet, height, whether it is in kilos, pounds, anything. We don't care. And getting everything into the same format. So we will see why this is useful when we learn a lot of machine learning thing. And this data normalization or column normalization is an extremely important task that we will perform over and over again through all our modeling. So we also understood the geometric interpretation of data normalization. Now in the next session, we will study what is data standardization. There is some difference between normalization and standardization, which is a similar operation, but a slightly different operation. Fine. So in the next session, we will be studying data standardization. So this is all for the today's session. If you guys have any doubts still here, you can ask questions. I will be happy to answer it. पूछ सकते हैं
करंटली तो नहीं है, पहले इसको समझना पड़ेगा।
नहीं, इसमें आप थोड़ा सा, हाँ, फर्स्ट टाइम सुनने से थोड़ा सा अजीब लगता है, बट आप एक दो बार इसको समझोगे, करोगे तो हो जाएगा। और ये वीडियोस भी रिकॉर्डेड रहेगा, एक बार आप सुन लेना तो और आपको क्लैरिटी आ जाएगा।
यस,
ठीक है, बट थोड़ा मजा आ रहा है कि नहीं आपको?
हाँ जी। पहले शुरुआती में बोरिंग था, अब यहाँ पे आ गया क्योंकि मैथ्स आ गई।
देखो, जब स्टार्ट होता है कोई चीज तो धीरे धीरे एक एक चीजें आती है। अभी बहुत
हाँ
मजा आने वाला है, क्योंकि एक्चुअली मैंने थोड़ा सा मुश्किल पार्ट से ही स्टार्ट किया है। अभी अब आप जैसे डायमेंशनल डिडक्शन समझ लोगे ना, तो आपको अब जब मशीन लर्निंग एल्गोरिदम हम स्टार्ट करेंगे तो बहुत मजा आएगा आपको, बहुत तुरंत तुरंत चीजें समझ में आएगी। तो इसलिए मैं बोला कि थोड़ा ऐसे ही स्टार्ट करो इसको, तो आएगा मजा, कोई दिक्कत नहीं है। और फिर हम प्रैक्टिकली डेटा सेट के साथ समझेंगे इन चीज़ों को, तो और मजा आएगा। अभी तो जस्ट थियोरेटिकली मैं आपको बता रहा हूँ, वी विल डू डेटा सेट के साथ भी अभी समझेंगे तो चीज़ें। राकेश सर, कैसा आपको समझ में आया?
हाँ, आ गया।
और ठीक है, तो मैं अपना स्क्रीन शेयर ही हो जाएगा, खाना खाना कोई बुरी बात थोड़ी ना है यार।
नहीं नहीं, अनऑफिशियल
मैं उसको कट
अनऑफिशियल
कर दूंगा,
सीक्रेट्स
टेंशन।
गोज ऑफिशियल।
हाँ,
नहीं
मैं
नहीं सर, ये एक्चुअली मैं ये मैसेज देना चाहता हूँ